Hey, welcome back to the channel. My name is T-Cypher, and in this video we're going to be continuing on with the CNC build. In this video we're going to have a look at some of the parts that came from China. In the previous video I looked at the aluminium metalwork which came directly from Daniel Collins in Australia. So without further ado, let's make a start. Okay, so first piece out, I will say I'm making this video as a sort of side effect. I need to go through everything and make sure everything's present. So first off we have the drag chains. There's 4 pieces here. I think I'll need 3 in total, but I suspect what I'll end up doing is taking the links from one apart and adding them to other ones depending on the length for what I need. So there's going to be a drag chain that runs along the x-axis, the y-axis and the z-axis. Now these ones here, like I said, this all came from China. It doesn't look like you can open them up in situ, not that I can see at the moment. I need to pull them apart and try and understand them a bit more. But yeah, these are quite meaty to say the least. If I just move across a bit, we can have a look at the x-axis gantry there. Now we can look at that. As we can see, quite a bit bigger. Quite a bit. Sorry about that, my battery just died. So yeah, that was the gantries. I think I might have worked out how to take them apart, sort of damaged one in the process, so I'm going to have to do a lot more research on that. So I'll continue to see what else we've got in the box. So we have 4 of these cables here, where we've built what looks like a serial connection, and just loose ends. Now these will be the encoders for the closed loop stepper motor. So this comes with 3 Nm closed loop stepper motors. I think it's part of a kit. I don't want to see it as, you know, from AliExpress or something like that. But yeah, so there's 1, 2, 3, 4, all wired up, ready to go. Yep, so that's those. I'll put those over there out of the way. And in these boxes here, we actually have the drivers for the stepper motors. And like I said before, this is the section of the build that it probably scares me a little bit more. That's not really the right word, is it? But it's more interesting to me, different to me. Previously, I've used the Duet system, which has the drivers built in, so it's quite simple. So this is the hybrid servo drivers or closed loop stepper motor for these, and these are the HBS 57. So yeah, case looks like it's a little bit shifted a bit on this one, but I might be able to sort it out when I take it apart, open it up properly. So I've got 1, 2, 3, 4 of those. So that's for two stepper motors driving the closed loop stepper motors driving the y-axis, like in the Queen Bee. Correction, and the work bee for that matter. Okay, then in these boxes we have 2 off power supplies. Now these are S30-48, so 48 volts, 7.3 amps. It's got a Meanwell sticker on there, but yeah, not convinced. Fortunately with China, it's pretty renowned for its knocking off other companies, and we know Meanwell is a well listed part, and I will admit I had a little Google around Meanwell and I can't seem to see a Meanwell which is at 7.3 amps, so maybe it is Meanwell, maybe it isn't. Hopefully do the job. If need be, I'll replace those out at some point. So we've got 1, 2 of those, so those will be what's driving my stepper motors, 2 a piece. Mystery bag time. Quite light, no idea what it is. Give it a shake, nothing happens. Have a look what's inside. It might be the end caps, the blanking plugs for the linear rail, and like I say, I don't know. It's well wrapped, whatever it is. Interesting, it looks like it might be some sort of soap. Oh, it's a some sort of USB control board. Thinking about it, I'm pretty sure this is sort of standard issue with the stepper motor driver kits. I have noticed there's a Mach 3 disc in the kits, but given Mach 3 costs 140 quid, I suspect it's just again a rip-off, unfortunately. This is says copyright 2016 Bit Sensor Com, and it's a BSME Charlie Echo 04 uniform. Yeah, so I'm guessing this is some sort of driver board for Mach 3. So that will go in a spare cupboard, and I might have a look at it at some point, but I'm not going to be using it on this build. Like I said, I'm going to be using, in the previous video, UCCNC. Okay, this one I am 90% sure of is hopefully a 80mm clamp for my ATC. I've got an ATC spindle. In all honesty, this is where it all started. I've purchased an ATC auto changing spindle, and it didn't look like the initial metal hardware I had on the Queen Bee would do the job. I'd probably have to change out a servo motor, in all honesty. But being the numpty I am, I'd thought, bugger it, I'm going to build a nice big machine. So yeah, aluminium spindle, hold out. Hopefully it should work to fit to the metalwork straight away. And that is indeed 80mm. So that's the result. Okay, I will just pop this lot away and get the next lot to have a look at. Okay, like I said, CD, the best one. Yeah, no comment really. That probably also explains why it came with a USB cable. Then we have 4 proximity sensors. So these run on 0 to 36 volts DC with a maximum of 300 milliamps on the black, and the blue 0 volts. Okay, so those are my proximity sensors. So that's a change out from the work bee where I've used their microstrictures. Okay, and then in this box is the shiny bit. Well, I say shiny bit. Interesting bit. Almost certainly it's going to be the stepper motors themselves. There we go. 4 stepper motors. Like I said, these are 3 Newton meters. Oh, they're quite hefty. Can't easily show if I swing this around here. Let's do this. Okay, so we can see the stepper motors on the Queen Bee. These are twice the length, if not more. Okay, and yeah, and twice the length just purely in the important bit. So this is a closed loop stepper motor. If you don't know what this is, which in all honesty will surprise me, it's basically there's a feedback loop. On the back here we have an encoder. So this tells you the position, or tells the computer the position of the actual head on here, and that means it can accurately control the location. Why is this beneficial? Basically, it allows it to better control itself and not lose steps. It also helps and it improves the current draw, I believe, because it only actually it can alter the current depending on how its actual position is. But yeah, this is definitely a much more beefy motor. Fortunately, it's all in Chinese, pretty much. So yeah, that's going to be interesting. But that's the serial connector which goes on to the encoder, so that should be simple enough. And then we've got the 4 wires here. It's only a short little fly lead, so I'm also going to have to get some sort of extension onto there. But that's 4 of those. Yeah, proper meaty those. Yeah, and those I think are probably drawing, I think I read 3 amps, which is more than the, maybe even more than the, than 3 amps, which is more than the Duet could drive out. So if I could use these with a Duet, but I need to go out to a driver, stepper driver, and then to that, so it's a slightly different configuration. So I'll pause there for a second. Okay, now this looks like the more mechanical stuff. I've done a lot of research. I think I understand what most of this is, but I've not actually physically had hands on some of this stuff before. So these parts here all linked to the ball nuts. So the way it works is you have one side which floats and one side which doesn't, to put bluntly. So I would say, and that's just a locker. That it's got a bearing in it, so I'm guessing that's the fixed side. And I'm guessing this side, which doesn't look like it's got a bearing in it, or I might be wrong, is the floating side. See, there's a circlet there, so maybe that's the float and this is the fixed. Not sure. It'd be interesting when I get to it. So I've got 1, 2, 3, 4 of these ends, so those are almost certainly the float, and 1, 2, 3 of the other end, fixed end as I'm going to call it. So thinking about it, 1, 2, 3, those must be the fixed float end, those must be the rotating end, because I think, from what I can tell, there isn't a bearing block on the bottom of the Z axis. Then we have the actual Bonnet Mounts. So these are what actually, there we go. Well, that answers that question. I was getting worried about that. These are what the ball nuts mount into and connect to whatever they're moving along. And it looks like, I was actually a bit worried. I thought I was missing 3 of these, but obviously they've been stuffed in there, which solves the problem. So 1, 2, 3, and a 4th smaller one. I'm not 100% sure. I think the Z-axis may be a size 12, while there's a size 16. I'm not 100% sure on how all the ball size works, but yeah, that one definitely is a little more titchy than the rest. That's, like I said, let's have a little measurement. That looks like it's about an internal diameter of about 10 mil. And this one here, maybe that's a 12. So that was probably 10. So that's a 16. Yeah. So it looks like we've got more meaty ball screws on the long axis, which makes sense in all honesty, because that's where you're going to get the whip potentially. But yeah, I will say slightly disappointed in how the boxes arrived. Again, I don't know Daniel. It's potentially a combination of the Chinese supplier packaging it and how it's been treated in transit, because the bottom of the box is wet. There wasn't any sort of bubble wrap protecting any of this stuff from the outside action, so it's purely relying on the physical properties of whatever it is not being hit too hard. Maybe the stepper motors and look like they're well protected in polystyrene, so probably nothing damaged, but it does leave us in a situation where, like this box here, it's a complete state, it's been wet, it's cardboard, and yeah, just a complete mess. But yeah, enough of that. These are the couplings for the stepper motor to the drives. So I'm going to put these back in there because that was actually a really good idea. By just keeping them things neat and tidy. I'll give them that. Okay. So that's for those, like to be expected. And then we come to the actual carriages. If you saw my creamy build, I think those have carriages in them as well. These they look like Hewins, the Taiwanese ones. I'm almost certain they're not. They're going to be cheap Chinese knockoffs, but they'll do the job. These should be, if I remember correctly, 25mm. If I look there, that looks about 25, as opposed to, yeah, the Queen Bee has a 15mm one. And if we just come somewhere, so let's go, we can see them in the back there. If I take this somewhere close, you can just have some sort of idea how much physically bigger these are. These are, I would say, a good 2-3 centimeters longer, centimeter and a half wider. I know I switch units, millimeters, centimeters all the time. I'm sorry. I don't do imperial. I do apologise. Okay, so that's one of them. I'm going to go through each individual box, but I'll do that off camera. It's got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So that is correct. And that is 4 per each axis, yes. So that's those bits. Let's see what we find next. Okay, so this particular box I'm not going to go through in massive detail. The kit that Daniel surprised me with actually included all the fixtures and fasteners this time around. I don't know if you remember when I did the Queen Bee, it was a bit of a... They sent out a list of bits you need and I sourced those locally, but this time I've got basically a box full of lots of different size nuts and bolts and things like that. So we can see here it's included some good slot in T-nuts. So these are the type that you can place in, rotate and then lock in, which is a bit better than the initial ones I was using last time around. A lot more meaty. So bag of, I think these are the M6 ones. I think there should be about 150 of those. I'm not going to count them. Hopefully there's more, but I'm not going to be able to count them. They're just impossible. And then these ones, these are M8, so bigger hole on there. So yeah, so you can see the difference. Yep, but the actual runners are all slots. I want to say 8mm slots on the 4040. But yeah, yeah. So massive box worth of stuff there. I'm not going to go through it all, but it's all the bolts there, the gussets or corner pieces for the extrusion, some feet for the extrusion, also 5mm spacers. Let me just grab them. Yeah, bag full of 5mm spacers. I probably have a lot of these already because I do have leftovers from the Queen Bee build. So yeah, so those bits. Let's see what I can find next. Okay, so now the final section. As I assume you guys aren't really interested in seeing a pile of bolts and screws and nuts and things. So these are the final bits of hardware I'm going to show you. I have got more hardware off screen, but to put it bluntly, they're a lot bigger, so I don't see any value of it showing you, and it's just variations on what you see here in front of you. So first I'll look at this. This is the linear rail for this bonnet. It's 25mm rail. Okay, so quite a lot more beefy than the rail used on the Queen Bee. So if I just come down, because we're on a Queen Bee here, you can just see next to each other. It's the other one was 15mm. This is 25. You can see it's considerably bigger. Okay, and yep. So we take our little HGR blocks, which are probably full of oil, which is fine because it's for transportation. If it's not sealed, I'll open one up. Oh, they are sealed. Okay, I won't run it onto the rail, but trust me, it'll fit. It'll run up nicely. I'll probably give these a clean down with IPA and re-grease them before I build. But yeah, that's 400. That's the Z-axis, so that's going upright, so that's quite a big length. 2 on the Z, then there's 2, be just short, probably 950 or something on the Y-axis, and which is goes left to right as you look at it from the front. It's correct, that's the X-axis, and then it's about 1495 I think on the Y-axis, which is a long one, so quite long ones. I am glad to say these were slightly better packed than the other bits and bobs. They're at least wrapped in some foam and in a cardboard box, and this box doesn't seem to have taken as much of a beating, so that's a bonus. So get those out of the way. Get that out as well. Okay, next up we have tubes. Okay, so these, or the bowl nuts. Okay, so this is a bit of tech I've not got any previous experience with. The normal Queen Bee as we stand right now uses an Acme thread. The Queen Bee 2 is literally just releasing. That is using a smaller ball screw, or it might even be, yeah, it is a smaller ball screw system than the Nighthawk. So if I get this out, it's quite a tight fit. Okay. I've not had this open yet, so let's have a look at it together. So this is the smaller size thread. I think this is a 12mm. So open up on either end. Now it's sealed at the moment. Let's just get a knife quickly, be right back. Okay, so open this up. This is probably covered in grease, which is fine, it protects it. Actually it isn't. Okay, so there we go. So that is the ball screw for the Z-axis. Okay, runs back and forth. Okay, this is new tech for me, like I said. So yeah, but if we can't really show it too well here, but it looks to be about twice the diameter of the Acme thread I've got on this Queen Bee. I'm not too sure if the what size the Queen Bee 2 is using. I think it might be using this for X and Z, X and Y, and maybe something smaller for Z, or it could be using the next size down. This looks like about 12mm diameter. They could be using a 16mm diameter. So that's that. That's quite interesting. And this is its bigger brother, hopefully. I was slightly worried at first when I saw these cardboard splits, but I think it's just a side effect of the actual ball nut. So I'm not as worried about it now. Let's get this off. Actually, let's just split it out here, because this is probably the easier way of doing it. Yeah, there we go. Okay, so this is the ball screw for the X-axis. Again, these were shipped in these cardboard boxes. See, it's bubble wrapped, and then the actual entire lot was bubble wrapped, I think, in another cardboard box to try and protect them on the journey. I know, reading on other forums, people have had bad experiences of bent ball screws and severely damaged ball screws in the past during shipping, but I think the cardboard tube is sort of becoming the go-to way of doing it, and it provides a protection level. Okay, so here we go. You can see there's definitely some oil in this one. Okay, let me just get it out. Okay, well, we can see that is a lot more meaty than even that 16 we just had a moment ago. You can see that side by side, and then if you oppose that to the Acme, which if I swing it around here, we can see one in there. If I bring that up against there, you can see it's just so much bigger diameter. And the benefit of that is that it will help to reduce whip in the longer axes very nicely. So some grease in there. I have to do some bit more research on these, see if I need to do any cleanup or anything on them, or whatever. But yeah, another interesting part. Okay, and I'm just going to pause for a second to get these out of the way.